Hey class, welcome back. This week we're going to be discussing Octal or base 8 numbering system. So just as kind of a reminder of what we know already, the numbering system that we're familiar with is base 10 or decimal, the decimal system, right? And we know that that's based on basically the number of fingers we have. And we have 10 fingers, that's kind of where we came up with our numbering system. And we've also discussed binary or base 2, and that's the language that computers use, or the numbering system that computers use. And computers do use binary, but because of the extent of how many numbers it takes to create, larger numbers, right? Our base 10 number 100 would take like 5 digits or 6 digits. I forget what it is off the bat, right? So what they actually do is computers use what's called a hexadecimal system, which really shortens it, or occasionally they'll use this base 8 or octal system. So this week's assignment, you guys are going to be learning how to convert between base 10 to base 8 and base 8 to base 10. So I guess the first thing I want to show you is just kind of how to convert between base 10 to base 8. So we'll do a simple number. We'll do, let's do 42. That's our base 10. And what does that equal in base 8? Well, just like before when we did going from base 10 to binary, we're going to build our scale. And we're going to break it down, right? And the good thing is you really don't have to do a lot. We're not going to get too many more than, 4, probably the most in this assignment, maybe 5. So originally we did, remember a lot of times people would shorten it to just 1, 2, 4, 8, 16, 32, 64. What those numbers really represented they were 2 to the 0 and 2 to the 1 and 2 squared and 2 cubed and 2 to the 4th and so on and so forth. But that's because we were going to a base 2 system. So now what we really want to do is we want to go, instead of base 2, we're going to base 8. So I'm going to make this 8 to the 0, 8 to the 1, 8 squared, 8 cubed, 8 to the 4th, and I know I'm not going to need that. 8 to the 0, as we know, is 1. 8 to the 1 is 8. 8 squared, 64. 8 cubed is 512, and we're not going to need more than that. So, same process before, right? We want to see how can we get to that? So we start with our biggest number. Can we fit, is 42 bigger than that? Yes. Is 42 bigger than that? Yes. Is 42 bigger than 64? No. So I can't have 64 and 42. So this is going to be a 0. There's 0 of these. It's too big. And likewise, it's going to be 0 and 0. So you don't really need these. So we're only going to have a 2-digit number, which again, you can see right off the bat is less digits than a binary system. But now I have to determine, I don't just put a 1 here like we did in binary. Now I have to determine how many. How many 8s do I have in 42? And I have 5, right? So just like before, I'll take my starting number. I'm going to subtract. 8 times 5 is 40. And do subtraction, I'm left with 2. So that's really the biggest difference here. You can't just put a blanket 1. This number will never be bigger than 7. So in the binary, or in our binary system, we had 0 and 1. In our decimal system, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's our decimal system. For octal, we have 0, 1, 2, 3, 4, 5, 6, 7. Nothing will ever be bigger than 7. So you'll never have an 8. This could be anywhere from 0 to 7. That's the octal. Obviously it has 8 different numbers, right? This is 1, 2, 3, 4, 5, 6, 7, 8 different digits in an octal system. You guys are familiar with octal, right? Octagon has 8 sides, octopus has 8 legs. Our octal numbering system has 8 digits. And that's why we have to do the multiplication. 5 times 8 is... And the last one, we have 2 left. How many 1s do we have in 2? We have 2. 1 times 2 is equal to 2. We subtract, we get 0. So we know that 42 base 10 is equal to 52 base 8, because that's what's left, 52. And that's our answer. So when you guys are doing these problems, make sure you're drawing out your scale, showing your subtractions. I want to see that. Obviously, you could just do like Google convert to convert them. I'm not interested in you guys knowing how to Google this. We'll do another example just in case. If you're comfortable with that and you want to just go right for it, you guys can skip ahead. I'm going to do, let's do 125. We'll do 125 base 10 equals what? And base 8. Again, we build our scale. I know I'm not going to need too many. 8 to the 0, 8 to the 1, 8 squared, 8 cubed. So this is 1, 8, 64, 512. Do I have 1? Yes. Do I have 8? Yes. Do I have 64? Yes. Do I have 512? No, I don't have 512, so I don't have to worry about this at all. How many 64s do I have in 125? 64 times 2 is 128, so I don't have 2, so I only have 1. Bring it out, 125 minus 1 times 64, which I know is 64. 1 times 64, 64. I do the subtraction. 5 minus 4 is 1. 12 minus 6 is 6. So I'm left with 61. Do I have 8 and 61? Yes. How many 8s do I have in 61? Again, this is the biggest difference. So 8 times 7 is 56. So I actually have 7, the maximum amount you can have. 8 times 7 is 56. So do the subtraction. 61 minus 56 should be 5. Do I have 1 and 5? Yes. How many? I have obviously 5 of them, right? So 5 times 1 is 5. Do the subtraction. We get that. And our answer would be 175 base 8. And that's equal to 125 base 10. And again, one way for you guys to check yourselves, a base 8 number, 175, should always be bigger than your base 10 number, 125. Obviously, 0 through 7 are going to be identical. And anything past that, you're actually going to have a bigger number for base 8. So that's just a really quick way to check yourself. If you end up getting just 75 there, 75, that's smaller than 125. I know I made a mistake there. I forgot the one. It's 175. That's just a good check for you. So now what I want to do is, let's just go the opposite way. And we'll say, let's go from, let's do a small number, 19 base 8. And we want to convert that to base 10. What does 19 base 8 equal? Well, just like before, oh, look at me. I already made a mistake. We can't have a 9 in base 7 or base 8, right? Highest we can go is 7. So let's make this 17. Hopefully you guys would have caught me if we did this in class. 1, 7. And again, we're going to build our scales. This is 8 to the 0. This is 8 to the 1. So 8 to the 0 is 1. 8 to the 1 is 8. So now, when we bring them down, we're going to do the same thing we did for binary, but this time you have to multiply them. So 7 times 1 is 7. Put a little plus sign. 1 times 8 is 8. 8 plus 7 is equal to 15. So I have 17 base 8 is equal to 15 base 10. 15 is smaller than 17, so that looks right. And there you go, that's your answer. And you guys, again, you could actually Google this just to verify your answers. It's really straightforward. I'm not going to provide a solutions manual because you guys can just simply Google your answers and see if you want to check your work. And let's do just a slightly larger one. Let's say we want to do 200 base 8. What does that equal to in base 10? And again, skip this if you feel comfortable, but we're just going to break it out. 2, 0, 0. Draw my tracks. This is 8 to the 0. This is 8 to the 1. It's 8 squared. So this is 1, 8, 64. 2 64s is 128. Plus 0 times 8 is 0. Plus 0 times 1 is 0. So 200 base 8 is equal to 128 base 10. And again, this is smaller than that, just a good way to verify. We could always Google it. And there you have it. That's pretty much what you guys are going to be doing this week. Next week, we'll get into hexadecimal, and I'll go over a few more interesting, cool things about how they can correlate between hexadecimal and octal and binary. They're a little bit easier to go between than decimal, which doesn't make sense for computers. Good luck. Email me if you have any questions. Again, you guys are just doing the odd problems, so you don't have to do every single one. I just want to make sure you guys are comfortable with it. So good luck, and I'll see you guys on Wednesday.